Hello guys, thanks for watching my video. Today we are going to look at geometry, okay? Then is mainly triangle, okay? Triangle. So we have to prove one theorem, then is basic proportionality or theorem or Thale's theorem, okay? This is a theorem proved by this Thales, or he himself developed this theorem, okay? So the statement states that if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the other two sides in the same ratio. Okay? Okay. I think you know the meaning of this statement. Okay? So first, when you do a geometry, okay? First, using this statement, we are going to draw a figure, right? Now, given one is given here, a triangle ABC. Okay, ABC is a triangle, and a line DE parallel to BC intersecting AB at D and AC at E. Meaning, if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the other two sides in the same ratio. So, from this to this is a given, and from this to the last will be the proof. Okay, so so let's see the figure here. I draw the figure here a little late here. Here, given that ABC is a triangle, okay, and if a line is drawn parallel to one side of a triangle, now let's draw a line. This is a line parallel to one side, okay. This parallel with this side, we just name it DE, okay. One side of intersecting the other two sides, meaning since when we draw this line intersect this AB at D and AC at E, okay, then is the given here what it means. Now what we're going to prove is that it divides the other two sides in the same ratio, meaning this other two sides AD, DB and AC, no sorry, AE, EC, okay, meaning AD is AD by DB equals AE by EC, then it divides the other two sides in the same ratio, okay. This is what we are trying to prove. Now let's do a construction, okay. So join BE, CE and draw CF perpendicular to AB and BG perpendicular to AC. Why we do construction in geometry is that to prove a theorem or any equation, okay, if you do a construction, it will be easier to prove, okay. So it will be an easier way to prove, but without construction also, if you can prove it, then is no harm, okay. But if we do a construction, that will be easier to prove or require answer, okay, what we are trying to prove. So construction. Now join BE. Now I join BE, this dotted line, and CD, and then draw CF perpendicular to this AB. Perpendicular means it make this here 90 degree, okay, and here also 90 degree. So now in this figure we have that. Now we are trying to prove. Now in this figure, if you look this figure, this AR is area, okay. This AR means area. This area of triangle DBC, if you see DBC, well, DBC meaning this triangle is something like this, okay. This triangle, okay, this dotted line, this triangle and this triangle will be equal in the area, because I think there's one theorem, okay, that in any triangle that this area and this area are equal, okay. That though I'm going to prove in my next video maybe, okay. So anyway, in this video, let's say that it is true. Okay, so area of triangle DBC. So if you see DBC, meaning this triangle, and area of triangle EBC. So this triangle and this triangle are, the area are equal. Okay, then is number one, equation one. Now and area of triangle ABC minus DBC. Area of triangle ABC, where ABC is the biggest one, minus DBC. DBC, this part will be, this area minus this part will be ADC, right? It will be ADC, right? ADC, this triangle, which is equal to area of triangle ABC minus this. If you take out this, meaning if you take out this, you will get this triangle. Another here, if you take out this will be like that. Okay, this will be the triangle. So these two areas are equal again. Okay, same theorem here. So which implies that if you subtract ABC minus DBC, so if you subtract them out of ABC, if you subtract them, you will get ADC, right? ADC or ACD. So area of triangle ADC is equal to area of ABC minus EBC. So if you subtract this, you will get AEB, right? AEB or ABE. So AEB. Okay, this is question 2. Now from these two equation, now dividing. Okay, if you divide it, because it is a ratio. Okay, in terms of ratio, that's why we have to divide it. So these two area, if you divide it, so area of triangle ADC, this one, upon area of triangle DBC, go to area of triangle AEB upon area of triangle EBC. Okay, so one is the area of triangle. So area of any triangle is nothing but half times base into altitude, right? Then is the formula of area of triangle. So applying that one, so area of triangle ADC will be half of, if you see ADC, where is ADC? This is ADC. So ADC, so half into, so I have to take base to be AD, because what we are trying to prove is this one. Okay, that's why we have to take the base. You can take this base or this also, or you can take this also, but we have to see with what we are trying to prove. So we have to take AD as the base, and what will be the perpendicular distance or the altitude? There will be CF. Okay, this CF will be the perpendicular distance, okay, or altitude. And area of triangle DBC, where is DBC? DBC, this triangle, this small one, will be base. I have to take base as DB. Okay, half into DB into, so here also perpendicular distance or altitude will be CF again. So CF. Okay, here. And area of triangle AEB, this will be, the base will be AE, so half times AE into perpendicular distance will be BG, right? Upon area of triangle EBC will be half into EBC. EBC is this triangle. Okay, so base will be EC and perpendicular distance will be BG, right? This BG. So the base, though, you can take any of them. Okay, in this triangle you can take this, either this, okay, but we have to choose carefully such that we are trying to prove, so that we can get this or required answer. Okay, so here you can cancel, right? Half CF, half BG. So you can get AD by DB equal to AE by EC. So this is the proof for this Thale's theorem or basic proportionality theorem. Okay, I hope this is clear. Okay, if you have Not if you are not clear with this, okay, we can do another video also, okay. I hope this video is helpful for you, okay. That will be our the end, okay.